it's reasonable to assume that different aspects of the same machine learning task take different amounts of time to learn. Because of that, I'm interested in exploring a mixture of learning rates in our model. One danger with this approach is that stretching our gradient steps along one axis but not the others will cause us to descend in the wrong direction. To that end, I think we should discretize our learning rates into a small number of groups and interpolate our mixture of learning rate layers with just normal layers. It could be fun to apply this technique to online training in continuous control tasks. We could learn a dynamic policy that adapts to the current circumstances. Unfortunately, this lies in the face of recent work such as fixed Q targets and experience replay. I'm really excited to try this one out.
It turns out my idea doesn't have practical value. The results are still interesting. The implementation. This function can decorate any optimizer. At each step, our decorated optimizers find marked layers in our network and transform their gradients before backprop. The experiments. We're working with a ResNet 18, 8 marked layers on Zephyr 10. Half our marked features will train normally, the others 100 times faster. Fast features dominate, determining hyperparameter thresholds required for stable training. We trained at 1/1000 for 5 epochs, and then gradually increased the learning rate over 7.5 more epochs. Our loss diverges, then explodes, runs up this chasm wall, and stabilizes in a huge basin. The gradient trajectory seems to have both micro and macro behavior, whose interaction leads to this odd path, perhaps trying to ignore unstable features. Without mixtures, everything is plain sailing. We can train with higher learning rates, underfitting on the left, overfitting on the right. After tuning the hyperparameters, both optimization methods perform equally well, with and without momentum, mixtures orange, validation underneath. That said, it's very difficult to overfit a network trained with mixed learning rates. Like before, our gradients quickly explode near the tipping point. I won't be training production models with mixed learning rates, but perhaps they can be used to help understand the limits of momentum by providing consistent failure modes for researchers to analyse. That's all for this week. I apologise for the limited amount of content, but will continue to produce new videos. There won't be enough time for much original science, but I'm sure we can think of fun things to do. As a reminder, I'm actively working to start my machine learning career. Your help would be greatly appreciated. Contact information in the description.